All right, so we are here to go over our our exit ticket from yesterday. And it's only 5 questions this time, so you should be able to, or you should have been able to manage that in your 5-minute span. So let's get started. So this is a research summary, so these are going to be questions about experiments most of the time. So let's go through it. All right, number 1. Which conclusion is best supported by the results of experiment 1 alone? So I need to look at what experiment 1 is about. The following experiments were performed by a chemist. Experiment 1. Hydrochloric acid was added to samples of 4 unknown solutions labeled 1, 2, 3, and 4. A white powder precipitated out of 1, 2, and 3. No precipitate formed in solution 4. So we had our samples, right? If we look at here, we added, so we had solutions 1, 2, 3, and 4. We added that to it. And this precipitate came from 1, 2, and 3. So we can take 4 out. Okay. So, silver ions are present only in solution 3. We can't guarantee that yet because it had the same results as 1, 2, and 3. No ions are present in solution 4. Lead ions are present in solution 1, 2, and 3. We can't say no because they didn't test for every single ion. Lead ions are present in solution 1, 2, and 3. We can't tell that yet. All we know is there is a white powder. No positive ions of silver, mercury, or lead are present in solution 4. So here, look at here. We know that the white powder means lead, silver, or mercury, but we don't have any of that in solution 4. So no lead, silver, or mercury in solution 4. The answer to note number 1 is D. All right, based on the experimental results, which ions did solution 2 contain? So let's see. Each of the samples was placed in a 100 degrees water bath. Precipitate in solution 1 redissolved. Solution 2 and 3 still contained the white powder. Solution 4 was unchanged. 2 and 3 were centrifuged to remove the precipitates, which were retained. Potassium chromate was added to each sample. A bright yellow in 1 and 2. And none formed. The white powder centrifuged from 2 and 3 was treated with aqueous ammonia. The precipitate from solution 2 returned into solution. Okay. So, we heated it, lead dissolves, AgCl and mercury, so silver and mercury remain, and that was in solution 2 and 3. We added ammonia, and AgCl dissolved, that's solution 2, but solution 3 remained. And then this is a yellow precipitate in 1 and 2. So, where can we map down 2 and 3? So, number 2, lead ions only. No, because we know it has silver, so yeah. That's a lead, and it goes back. All right, silver and mercury ions only, maybe. Silver ions only, maybe. So now we need to decide between G, H, and J. So how can we cancel out the silver? Here, so each of the sample solutions, 2 and 3 still contained a white powder. Solution 4 was unchanged. 2 and 3 were centrifuged to remove the precipitate, which were retained. Potassium chromate was added to 1, 2, 3, and 4. A bright yellow precipitate formed in solutions 1 and 2. None formed in 3 and 4. The white powder centrifuged from 2 and 3 was treated with aqueous ammonia. The precipitate from solution 2, so we know it has silver. And then this one was mercury, but we only see this in solution 3, so that means that it came from a solution that had lead. So we're lead and silver, we're not mercury because that's solution 3. All right, number 3. The yellow precipitate that formed in experiment 2 was most likely what? So yellow precipitate, this is solution 1 and 2. And we have lead and Cl2 and K2Cr4. So it's going to be something with lead in it. So it's probably a mix between what they added. And that is a mix between original and added. That's it for number 3. All right, 2 more. You're almost done. Number 4. The experimental results suggest that if lead chloride were treated with aqueous ammonia, the results would be what? So, let's look here. Lead chloride. We treated it with potassium chromate. We never treated the lead with aqueous ammonia, so this did not happen. That was supposed to be an X, not an equal sign. That did not happen on our graph. So that's going to be J, because we did not test NH3 on lead. All right, number 5. A student proposed that the analysis could be carried out more efficiently by heating the samples to 100 degrees before adding the 6 molar HCl. So let's see. If we wanted to heat it before, let's see what happens when we heated it. This was placed in a bath for 15 minutes. The precipitate in solution 1 redissolved. Okay, so the precipitate in this redissolved, right? So this part dissolves in the heat. And we don't necessarily want these things to dissolve. We want them to come out of solution so we know what they are. So it's not a good idea. Now let's figure out why. Since PbCl2 will not precipitate out of solution at this temperature, lead ions would be undetectable. Yep, that works for me. There we go. Also, do you see how this relates to the experiment? And this does not. This came up with some like method that we didn't talk about, but this talks about results. And there you have it.